Now we're going to solve systems of equations using matrices, and the first method I'm going to go over is called Cramer's rule. This is probably one of the longer methods, but at the same time, if you only need to find one variable or something, it can actually help you isolate, especially if you have multiple variables going on. But let's talk about how we find Cramer's rule here. The first thing we need to do is we're going to set up one more matrix than we have variables. So if I have 3 variables, I will have 4 matrices. My first matrix I'm going to label as just D. This will be all of the coefficients of all my variables. So I will have 3, 2, negative 1, 2, negative 1, 3, 5, 7, negative 2. So that is my first matrix. My second matrix I'm going to label as dx. This time I'm going to take all of these matrices in column x and take them out and replace them with these constants down here at the end. So I'm going to just do that first column here so you can see what I mean. So I'm going to have 4, negative 2, and 12. Everything else about these matrices stays the same. So if you're looking at this, I have constant yz, constant yz. All right, then I'm going to come over here, I'm going to do the same thing, and I'm going to make a dy matrix. I'm going to put all those x's back in. But since it's dy, I'm taking all the y's out, and I'm putting the constants in that location. So I'm going to have 4, negative 2, and 12, negative 1, 3, negative 2. So for dy, I have x, constant z, x, constant z, x, constant z. All right, and then my final matrix is going to be dz. I put the x's and the y's both back in. So I've got 3, 2, 5, 2, negative 1, 7, but now my constants go here. So 4, negative 2, and 12. So I have x, y, constant, x, y, constant. So the letter on my name of my matrix is the variable coefficient that is missing. All right, at this point in time, we would type all these into our calculator. And this is where it gets a little bit tricky if you don't have a TI-84 calculator. Because now we need to find something called the determinant of each of these matrices. You could probably find a determinant calculator if you just Google search for one. But I'm going to use a TI-84 because at my school, that's typically what we'll use. So I'm going to start here, and you're going to go second matrix. All right, I'm going to do a couple things here. Let me move this. So second matrix, and if I do this, then you can actually see my key sequence down here at the bottom. Okay, the first menu that comes up is names. I don't want to mess with that. I don't want to do any math yet. I want to edit an actual matrix. So I'm going to go in and edit matrix 1. The first thing it's going to ask you is the dimensions. This is how many rows by how many columns. Well, ours is a 3 by 3. And then I'm going to go in and type them in. So this will be our matrix D. We're putting in matrix A. So 3, 2, not 32. Oops, sorry. 3, 2, negative 1. It doesn't like how I did that, sorry. All right, then 2, negative 1, 3, 5, 7, and negative 2. All right, I would check one matrix before you go through and do them all. Because if the D matrix, so if this matrix right here has a determinant that is 0, we actually can't solve this. This has no solution. So let's check the determinant of this matrix before we start. The way we do that, so we got to quit out of this menu and get back to our home screen. So second matrix, now we want math. This DET, this menu number 1, stands for determinant. So we're going to go enter, and we're going to say, okay, second matrix, I want the determinant of matrix A. I'm going to type that in there, and I get a number, so that's perfect. So the determinant of this matrix right here is a negative 38. So I'm going to write that down. All right. Then I'm going to go through and now I'm going to do the rest of those. So I'm going to edit matrix B. This will be my dx. Once again, it's a 3 by 3. 4, 2, -1, -2, -1, 3, 12, 7, -2. All right. Second matrix, we're going to do the determinant, but this time we're going to do the determinant of matrix B. And we get a -10. So the determinant of this is -10. You're going to go through and you're going to do this for these two matrices again. I'm not going to actually show you how to do this because I just showed you 2 of them, so I feel like you should be able to do that much right now. Okay, these are the numbers I got when I did the determinant for those other 2 matrices. So once you have all these determinants, the idea to find your actual ordered triple in this case. So we're going to have an ordered triple. What we do is we'll have the determinant from dx divided by the determinant of d. Then we'll have the determinant of dy divided by the determinant of d, and the determinant of dz divided by the determinant of d. That is going to be our answer here. So let's see if we can do this. 10 divided by -38, or -10 divided by -38. Then we'll have -54 divided by -38, and 14 divided by -38. Now, I don't know how other teachers feel, but I will tell you in my classroom, this is not an acceptable answer. All of these fractions need simplified. So 2 negatives make a positive. Everything's divisible by something else, so we do break it down. I do not want decimals, but I do want them simplified. So if I go through and I simplify all these fractions, I'll end up with a positive 5 over 19, a positive 27 over 19, and a negative 7 over 19. This is the answer I'm looking for with Cramer's rule. Now, if it was a word problem, you obviously would not put it in ordered triple format. You would actually answer the question. But Cramer's rule, like I said, this is probably the longest method. So let's talk about the next method that we're going to do, which is matrix equations. This is another one that uses the idea of division, but you can't really divide with matrix. You multiply by the inverse. And so let's talk about how we would set this up. We are going to set this up with matrix equations, and I'm going to try and do this by typing. We'll see how it works. So I take all the coefficients out. So 3, -2, and 1. Then 1, 3, -2. And then 2, -3, and 4. All right, so those are my coefficients here. And so that's my first matrix. Then I'm going to have times, and now I'm going to type in my variable matrix. Well, my variables are x, y, and z. So that's my next matrix I'm going to deal with. And this is going to equal my constant matrix. So my constant matrix is going to be 5, -1, and 7. So 5, -1, and 7. And recall that you cannot divide with matrices. When we are dealing with work with matrices, you cannot divide these. It'd be much easier if we thought of this as -2x equals 5, and then I could just divide, but that is not the case. So what we're going to do is we are going to type this in the calculator and your calculator to solve this. So we're going to type this into matrix A and this into matrix B. So once again, on our calculator, I'm going to move things so I can see what I'm doing. So we're going to go second matrix. Here, let's reset this down here. So second matrix, we're going to go over to edit. Our first matrix is still a 3 by 3. But now I'm going to have 3, -2, 1, 1, 3, -2, 2, -3, and 4. Then I'm going to go second matrix and go to matrix B. This time it is not a 3 by 3, it is a 3 by 1. So I do that. So 5, -1, and 7. Feel free to pause the video to be able to type things in or whatever if you need to with the calculator. All right, once I have those both typed in, what I'm going to do with this is, since I can't divide, I'm going to say, okay, well, X, Y, and Z. So this matrix right here is going to equal, if I were to take matrix A and do the inverse of it, times matrix B. So I'm going to type that in the calculator, and let me show you how to do that. So quit out of this so we get to our home screen. I'm going to clear everything there. So we're going to go second matrix, and now I want matrix A. So matrix A, my inverse button, if you notice, is right here. So it's kind of not the second matrix, it's just the without the second there. So A inverse times second matrix and B. I will stress the order matters. You have to do the inverse one first, otherwise it will not even multiply, if you recall how matrix multiplication works. Now, these decimals aren't terrible. I would actually accept those as the answers, but RTI-84 calculator is nice. It does do a math inner, and it will change decimals, even in matrices, to fractions. So our final answer here, I'm going to go ahead and write the fraction form just because I think that's what I have on my calculator here. So it will be 32 over 25, -1 over 25, and then 27 over 25. So this is our answer to this system of equation. All right, and this is what I call the middle method. Cramer's rule to me is the longest, matrix equation is the second longest, and you may be thinking, hey, that's not really long at all. But augmented matrices, super, super short. And actually, I'm going to type that here so we have it, augmented matrices. So with augmented matrices, we actually type all the numbers in all at one time. And it's all the coefficients. So once again, we're not typing variables in. So we're going to have 3, -2, 8, -2, 4, 1, 4, 12. 1, we're missing the y, so we put a 0, okay, z, and then 5. All right, this is our augmented matrix. Now, I do a couple things to just kind of separate some stuff here, but your calculator is not necessarily going to do this. I draw a little line here. So these are my coefficients, these are my constants. My goal is to get this side to be 1, 0, 0, 0, 1, 0, 0, 0, 1. This is what we call the identity matrix. And if you recall, all of these are x's, these are y's, and these are z's. So we're saying that our 1x, no y's and z's, our 1x would equal whatever this is. Our 1y would equal whatever this is. And our 1z would equal whatever this is. By hand, this is a very, very lengthy process. And in fact, I actually enjoy doing it just because sometimes I'm weird like that. But your calculator will do this, and I'm going to show you how. All right, let's flip-flop these screens. All right, so to do augmented matrices, we're going to go second matrix. Go over to edit, and we're going to type this whole matrix in. So it is a 3 by 4 now. I don't need to worry about the line that I added in. That's just kind of what it is. So I've got 3, -2, 8, -2. And I've got 4, 1, 4, 12, 1, 0, -2, and 5. All right, I've got this whole matrix typed in. Once again, you have to quit out of this screen, otherwise it doesn't work right. Now we're going to go second matrix, go over to math, but this time we're going to scroll way down. We are looking for RREF. This stands for Reduced Row Echelon Form. Okay, and this is what will help us solve this in one step. So we're going to do that, and then we want our matrix A that we just typed it in, and we get this. Oh Oh, buckets. That's an ugly number. But if you look here, we've got our identity matrix. We just have, what? Okay, well, that's why we do the math in our inner. Hey, that looks much nicer. That is how we write our answer. We'll write it as an ordered pair with fractions. All right. So let's write out our answer here. Feel free to pause this video at any point in time if I'm going too fast. I do want you to type these along in the calculator if you have one, because watching me do it and actually doing it yourself are two different things. All right, so we've got 62 over 19, 46 over 19, and our last one is negative 33 over 38. So one step, we have our answer. So like I said, I don't have a preference which method you like to use. For my students, I'm going to make you try all three of them, but then at the end of the day, you pick which one you like more. My preference is obviously this augmented matrices, but I also don't mind matrix equations. So I hope this helps, and I hope you enjoyed the video.